Assalamu alaikum and welcome to my new video related PIPESIM. In this video, we will see how can we put the hypos. Just for your information, this is the different hypos that I have on composition. It has glass fluid, so it has water, it has gas, and it has some condensate oil. So that oil is in terms of hypos, it's available. So we will see that how can we put these hypos in the PIPESIM. Okay, let's get started. So here, as I explained earlier also that there are two type of package. One called black oil and second is called composition. We have PVT, but we mostly doesn't use it. It's also a third party software. So if you go to composition, I will just make both of the things. So here are the fluid molecule. So here we have to select all the fluids. So let's start water with water. We have nitrogen. So nitrogen is done. Then CO2. It will come in carbon dioxide. Then we have methane and all those things. Methane, ethane, propane, isobutane, and butane, isopentane, and pentane. So these are already added. Now we will click on new. As we click on new, so it gives me the data, so I can put it as same like this and give you one. Name doesn't matter as you already know. So molecular weight is 86.18. Boiling temperature in Celsius is around 68.44. Specific gravity is will be so it will estimate also, but we have to update it. 0.664. Critical temperature will be 236.07. Critical pressure in bar, it mostly in bar absolute 30.17. In asymptotic factor 0.1. You can see some like critical volume where we get one. Here we have this also, but we don't need to put that. And then we click OK. And then I will put one more. So for this purpose, I'm not even going to simulate this. I'm just giving you the information that how can we put it. So I'm not going to put the whole for you. I'm just giving the information that how it can be done. It's exactly matching. So for now, I'm just going to put two only. If you go to edit, so if you go on edit, you can see. So we have all the components there. You can see NB1 and NB2. And then we can go to float, and that's very easy way to do it. Then you go to float, and then you know how to add the float. So for the composition, I will be just putting the composition for the gas and only for NB1 and NB2, and then we normalize. Of course, the main intent of this video was to show how to we can put the hypo components. Okay, so we'll put water, methane, ethane, propane, isobutane, butane, isobutane, and then one nitrogen, carbon dioxide, then N1 and 2. You can skip the next 30 seconds because I will be putting the composition definitely at time. And for the pipes in the best thing is that as soon as you put the composition, you get the phase envelope curve. That is very good to have. Even in ICs, you have to go inside the utilities and then you have to get the curve. But in the best thing of the pipe sim is that you get the phase envelope curve as you are putting the composition. So as you can see, this in this graph, the hypo components composition is very less. So we will only putting N1, NB1 and NB2. And if you see methane, methane is somewhere you are getting 40 was in the composition and you are getting somewhere. So that is because main is the methane. Yeah, this is the gross and liquid may govern, but this is just a random example. This is not any real life scenario. So after coding the composition, we will make the simulation as well. Just a one line simulation, and we will see all the things. So using methane is 40 and 44% somewhere, 45%. So it's okay. We can go forward. So just for the simulation, we will make a one line, one source we will add, and we will add one sink, and we will put one pipeline. Not more than that. Just to simulate the things. So since because this is a gross term adder or something like that, so mostly thing is the cylinder facility in which have the separators and all those things, which are mostly operated somewhere in 8 to 10 bar. We will put here 8 bar. And for the source, we will put the flow rate in kg per hour. Let's say let's we put around 15,000 kg per hour. Regarding the temperature, because this is coming from the vents, so this will have the higher temperature. Let's put 60 degrees, and we will specify the flue. So for the pipe size, I say no, no, this is not any example. Uh, let's put 8 or 10 inch. Let's go with 8 inch. So 8 inch we will put the pipe size. We will select some 40 or something like that. Where is the 8? Okay, better to type it here because I think the other pipelines. Yes, these are the API. 8 inch 40 will be good. For length, let's put around 10 to 15 kilometer. Let's put 15 kilometer and 1,100 elevation is good. So we are not changing any environment things, nothing else. And now we will just go and run the simulation. So it will take minimum some time to run the simulation based on your computer configurations. This is a very small network, so definitely it will not take more than 5 to 10 seconds. Now we have the results, and if you see the source pressure is converted into bar gauge, we are getting somewhere 20 bar. That's good. So temperature might be because we put the ambient as 15 degrees Celsius by default in PIPESIM. So we can go to the profile result and see what's the EVR and all these things. That's all the information. So if you see liquid holdup is more somewhere 10 to 15%, EVR is around 0.2, 0.1 to 0.2%. So we will make, so that's all man for today. We will see you in the next video with some new topic. Thanks.